pH and pOH. You've probably heard of pH. They talk about it a lot on shampoo commercials. If you have a swimming pool, you know you have to monitor the pH. pH is a measure of acidity. So if the pH is less than 7, we say the solution is acidic. pH greater than 7 is basic, and pH equal to 7 is neutral. And sometimes they're divided up into strongly acidic, weakly acidic. The pH scale is a logarithmic scale, which means it involves a logarithm. Not super happy with these slides. The pH equals the negative base 10 logarithm of H plus. What happens when you take the log of something? The base 10 log is asking what power of 10 is this number? And so if we deal with more straightforward numbers like this, 10 to the minus 4. Well, what power of 10 is that? It's minus 4. Well, we don't like negative numbers, so this minus in here is just to change the sign. The log of 10 to the minus 4 is minus 4. And then we change the sign, and that gives us a plus 4. This 4 comes directly from that 4. 10 to the minus 3. The log of 10 to the minus 3. You can try this on your calculator. Again, with my calculator, I put the number in first, and then I press the log button. Some calculators, you have to press the log button first and then put it in. So on my calculator, I would do 1 EE minus 4 and press the log button. And it gives me an answer of minus 4. And then I change the sign, and I get plus 4. So if you do that with this one, you press the log button, you'll get minus 3. You change the sign, you get plus 3. 10 to the minus 2, the log is minus 2. You change the sign, you get plus 2. If we look at a graphic representation of these concentrations, from 10 to the minus 4 to 10 to the minus 3, that's a factor of 10. So 10 to the minus 3 is 10 times as concentrated as this one. 10 to the minus 2 is 100 times as concentrated. And that's why we use the log scale, because otherwise we have this range from 1 mole per liter to 10 to the minus 14 moles per liter. That's 14 orders of magnitude. It's just huge, okay? And so we use the base 10 logarithms to compress that and make it a linear scale. So then we end up with numbers from 0 to 14. They do that with earthquakes too. The Richter scale is based on logarithms. So the pH is the negative log of the hydronium ion concentration or the hydrogen ion concentration. We use them interchangeably. Explain logarithms. Well, I kind of did, but let's just explain a little bit more. So if we have a number like 10 to the 5, the log of 10 to the 5th is 5. When we're dealing with numbers like 100, 1,000, a million, it's very easy to see what the log is. So if we look at a number like this, 100, the log of 100, what is that? 100 is 10 to the 2, right? So the log of 100 is 2. And if you don't believe me, do it on your calculator. 100 and press the log button. 2. Ten to the minus 14. The log of 10 to the minus 14 is minus 14. Log is just the power of 10. If we want the pH, then we're going to change the sign, say negative log. That's not anti-log. Let's just change the sign of the number, and then we just change this sign, and that makes it positive. Positive numbers are nicer, and so that's why we do that. what if we take, let's do one more in here. What if we do 10? What's the log of 10? 10 is 10 to the what power? 1. So the log of 10 is 1. So what if we do the log of something that's in between? Say the log of 50. Is that going to be 1.5? Halfway in between? No, because 50 is not 10 to the 1.5. So put 50 into your calculator and press the log button. 1.69897, blah, blah, blah. But 50 is between 10 and 100, and the log of 50 is between the log of 10 and the log of 100, right? It's between 1 and 2. Now try this. You should have a 10 to the x button on your calculator. So what if you raise 10 to the power of 1.69897? On my calculator, I do that by doing 1.69897 and pressing the 10 to the x button. What do I get? My calculator is showing me 49.999999995. Really close to 50, right? Because 50 equals 10 raised to the 1.69897 power. You can't do that. Yes, you can. You can raise a number to a power that's not an integer. Well, how could you take 10 times itself 1.69 times? Well, you couldn't, but your calculator can do it. 10 squared is 10 times 10. That's easy to understand. 10 to the 1.69897 power is a little harder to understand, but your calculator could do it. So what the logarithm button is doing is it's saying 50 is what power of 10? It's this power of 10. Weird number. Any questions? It's good to understand logarithms, but as long as you understand how to use the button on your calculator, you'll be just fine. So calculate the pH of each solution. Indicate whether the solution is acidic or basic. We forgot to answer that question on the previous one. Oh well. So hydronium ion concentration is 9.5 times 10 to the minus 9. Well, what does pH equal? pH equals the negative base 10 log of the hydrogen ion concentration, which here is 9.5 times 10 to the minus 9. So we're going to put this in 9.5 EE minus 9. Press the log button, change the sign. .02 is the pH. Is that acidic or basic? Well, there's two ways. We wouldn't have to look at the pH to decide. We can look at the hydronium ion concentration, and in a neutral solution, that would be equal to 1 times 10 to the minus 7. Is this larger or smaller than 1 times 10 to the minus 7? 10 to the minus 9 is smaller. If the hydronium ion concentration is less, then the hydroxide ion concentration must be more. This is basic. You can also look at the pH. pH greater than 7 is basic. pH less than 7 is acidic. Any questions? I want to show you something really cool about significant figures with logs. Let's find the negative log of 9.5 times 10 to the minus 3. Let's find the negative log of 9.5 times 10 to the minus 14. I'm doing these in my head. Are you impressed? You won't be when I explain how I'm doing it. Give me a number between 0 and 14. 7? Minus 7? 6.02. Check me, are those right? Let's do this last one. 9.5 EE minus 7 log, change the sign, 6.02. Weird, huh? Do you see the pattern going on here? What do these numbers have in common? The coefficient in scientific notation, the 9.5 is the same for all of them, and this one up here, right? What's the same in these pH values? The 0.02. Do you see a relationship between the 6 and the minus 7, 13 and minus 14, 2 and minus 3, 8 and minus 9? So 9.5 times 10 to the minus third is between 10 to the minus 3 and 10 to the minus 2. So the log is going to be 2 and a little more, because it's between 2 and 3. So this part of the number is 1 less than the exponent. Do you think this has any significance in terms of significant figures? Or is that a placeholder? Are these considered significant figures? No. Those are considered placeholders. That tells us how many places to move the decimal point over. These are the significant figures. So I'm not going to trick you on this, but I just want to show it to you that when we look at pHs, the significant figures are only the digits after the decimal point. So that's why I wrote 2 here. O2, 2 significant figures relating to these 2 significant figures. The number before just comes from the exponent and is not really a significant figure. It's important, but it's not a significant figure. So what if we're given the pH and we need to calculate the hydrogen ion concentration, which is what we're doing in lab today? Well, this is the equation. And for the mathematically curious, I'll just show you how I got that real fast. So pH equals negative log of the hydronium ion concentration, or hydrogen ion concentration, same thing. So I need to rearrange this equation and solve for H3O+, which is not as straightforward as the other ones we've been doing. The first thing I'm going to do is move that minus sign to the other side of the equal sign. I'm going to multiply both sides by -1. So I get negative pH and plus log. Now I just have to get rid of the log. Log is a function. I can't divide by a function. I have to do the unfunction, the anti-function, the anti-log. 10 to the x is the anti-log. That's why it's on the same button on your calculator. So I'm going to take 10 to the x of both sides. So 10 to the minus pH is equal 10 to the log of H3O+. H3O+. But 10 to the log of something is just that something. So 10 to the minus pH equals the hydronium ion concentration. So not going to test you on that, but just to show you where that comes from. So this is the equation. Calculate the hydronium ion concentration for a solution with a pH of 8.37. So pH equals 8.37. So then we have to use this equation that we just looked at. The hydrogen ion concentration equals 10 to the minus pH. So how do you do that on your calculator? So this is 10 to the minus 8.37. On my calculator, I go 8.37, and I change the sign to get it negative, and I press the 10 to the x button. On some calculators, you'll press the 10 to the x button first. It'll show you a parenthesis, and then you type in the rest of it. 8.37, change the sign to make it negative, and then press the 10 to the x button. So on my calculator, I have to press a yellow button first, and then I get the 10 to the x function there. So my answer is going to be 4.3 times 10 to the minus 9 molar. All these concentrations are in moles per liter. Are your calculators cooperating with you?